Alright, hey guys, welcome to the second lecture for ELEC 2607. Today we're going to be going over DeMorgan's Law, and then later we're going to be going over a little review on binaries. We'll be using that in the next lecture. So DeMorgan's Law here, it's just basically these two equations. This is a very simple form of DeMorgan's Law, and you can see if x or y is inverted, then it is equal to x naught and y naught. Now, if you take the dual of this equation, you get x and y inverted is equal to x naught or y naught. So very simple. In general, here you can see that when f doesn't have an inversion symbol, then everything stays the same. And then when you have an inversion symbol on f, then every individual element gets inverted. So just like in here, you can see that the f here is inverted. So now x is individually inverted, and then the y is individually inverted. And you can also see that the ors are switched to ands, the ands are switched to ors, and then the zeros to ones and ones to zeros. It's kind of like duality, and it is actually very similar in application, very similar to duality, but its purpose is to find the inverse of a circuit rather than finding a equivalent to another identity, which is the point of duality. So right here I wrote down basically the inverse equations for the DeMorgan's laws. So these basically just say that when you have a naught or b naught, and when you invert them, you'll get this result. And then when you have an and that's individually inverted, and then you invert the whole thing, you get just d or e. So these are also useful when it comes to simplifying equations, which we'll do an example of right here, and then we'll do more in the tutorial video. So let's go over some truth tables here. So, like, these truth tables, what I'm going to use them to do is just prove to you that that these equations are actually true, that the left side will equal right side. So, right now, let's go over the first equation. So, right here I'm looking on the left-hand side of the regular DeMorgan's Law equation. So, first I wrote down all the possible values for x and y. And now you have here x or y inverted. So normally when you take x or y, you have to look at the values, and if one of them is true, so 1, then you write down 1 here, or the whole value is true. But since this is inverted, we're going to be doing the opposite. So right now here we have 0 and 0. Both of them are false, therefore x or y is false, but it's inverted, so we have to write down a 1 here. Over here we have 0 and 1, and since we have 1, 1 here, we usually write down a 1, but we have to write down 0 because it's inverted. And same goes for the rest of them, because when both of them are 1 as well, it can also be true. But since it's inverted, it has to be false. Alright, so now when I'll individually go over x naught and y naught here, right? So first, let's take the naught values of x, and you'll get 1, 1, 0, 0. And now the individual values of naught y are 1, 0, 1, 0. So now I'm going to AND them together. And over here, and we know when you AND, you have to have both of them have to be a 1 for the value to be true. So here we have a 1 and a 1. I don't know if you can see that properly, but that's a 1. Then over here, x naught and y naught is a true. And it's not inverted because the whole equation is not inverted, just the individual elements are inverted. And that's why this is true here. Now we have a 1 and a 0. And since both of them are not 1, this is false. Same thing goes here, this is also false, and then both of them here are false. So this is also false. Okay, so that's the first equation proven. You can see here that the left-hand side is equal to the right-hand side. There we go. We have proven that DeMorgan's law works. Over here, I'm not going to go through the table the same way, but this is the proof that DeMorgan's law's dual also works. You can see I wrote down x and y values, and when you add together, I got the individual x naught, y naught values again, and then I ORed them together. I got this column. This is my right hand side this time, and then right here x and y ANDed together gets you these values, and then when you invert that equation you get these values. So right here you can see for both of these the left hand side is equivalent to the right hand side, so this DeMorgan's law works.